homework for today. You may want to take out your investigation notes from last week, if you still have them. Your goal for this is to figure out which one of these lines is the line it's talking about. It has to meet all of these clues. It's not a vertical line. The y-intercept is greater than -3. The slope is less than 1. It's perpendicular to another line on the graph. It's parallel to any line with a slope of 0. So I'll give you a few minutes to think about that. DYD.
Because the slope is less than 1 and it's parallel with any line that's the slope is 0.
Okay, what about the others? Does it fit?
Because it's not a vertical.
Is the y-intercept greater than -3? And is it perpendicular to another line on the graph? Which line? So it is D because it fits all of those things. Is anyone thinking any others? There are some that apply to some things, but not everything. So that was just to kind of remind you what parallel and perpendicular lines look like and things about them. Today we're going to actually define parallel and perpendicular lines. I'm going to have you write these down. Okay, so last class we investigated how parallel lines and perpendicular lines, like what about their slopes, what about the y-intercepts, and things like that. So the definition of parallel lines are lines that never intersect. We kind of touched on that previously. I don't exactly remember what we said when we talked about parallel lines, but they go in the same direction, they never cross, they never intersect, all those things are the same. They have the, algebraically, we know two lines are parallel, they have the same slope, and then I'm adding this other part in, and they have different y-intercepts, which we talked about before. In geometry, when you get there, you'll use parallel and perpendicular lines a lot. So these are the symbols you'll use. This is for parallel, just two vertical lines. Perpendicular lines, the definition are lines that intersect at a 90-degree angle. You'll talk more about angles in geometry. But we talked about that it crosses, it makes that T. Algebraically, we know two lines are perpendicular if they have negative, opposite, reciprocal slopes. So we talked about the slopes being flipped or reciprocals, one being positive, one being negative. So those are called negative reciprocal slopes. This is the symbol for perpendicular lines and upside down capital T. And then the definition for your negative reciprocal slopes are fractions that are flipped. The sign is switched. When you finish writing that, we're going to talk about some negative reciprocals. I asked, what is the negative reciprocal of 3/4? What would we say? We can say these out loud. I took that and I flipped it and made it negative. 4/3, but it would be negative. Negative 4/3. What about 2? I take it and I flip it and I make it Negative 1/2. Negative 7/8 would be positive 8/7. What about 1?
Negative.
Negative. Now, 0 is a little weird because if I have 0/1, which would still be 0, and I take it and I flip it and I make it negative, what is that?
Undefined.
Undefined. So 0 and undefined are negative reciprocals even though they don't look like it. So we have to remember that one because it will trick you. Try to, anyway. Right, so one part of parallel perpendicular lines is being able to determine is whatever you're given a set of points in equation, parallel, perpendicular, or neither. So we're going to do that. We are given points, so we have to find the slope. So I'm going to write off to the side what our slope formula is, just in case we've forgotten. y2 minus y1 over x2 minus x1. And then we're going to use that to find our slopes for the line segment AB and the line segment CD. Label them if you so choose to do so. So for AB, we have 6 minus 3 over 2 minus a negative 2. Or if you want to put 2 plus 2, because that's what it changed to, you're welcome to do that. What would the slope of AB be? 3/4. Right? Do the same thing for CD. So now we have 3 minus 0 over 3 minus a negative 1, or 3 plus 1. What would the slope of CD be?
Here.
3/4. So if we're looking at these two slopes, are these parallel, perpendicular, or neither?
Parallel.
Because they're the same. So you can either write out the word parallel or use the symbol. Questions on how we found those to be parallel? Let's try the next one. So number 2, the slope for AB would be 4 minus 2 over 5 minus 0. What is the slope of AB? Positive 2/5. And then if we're looking for the slope of CD, we have 3 minus 8 over 3 minus 1, which would give us negative 5/2, so negative 5/2. Would these be parallel, perpendicular, or neither? They are negative reciprocals. The fraction has been flipped, and there's one negative. The sign has switched. You can write out the word or use the sign. Simple. Let's do number 3. So for AB, we have 6 minus 8 over 2 minus a negative 1. What is the slope for AB? Negative 2 over 3. And then for CD, we have 3 minus 2 over 3 minus a negative 1. 1/4. So these would be parallel, perpendicular, or neither? Neither. this is an obvious neither case, so you would just write out the word neither. Because the numbers clearly are not anything to do with each other, not reciprocals, not the same. So that's an obvious neither case, but there are some that are not so obvious. So like if I had negative 2/3 and positive 2/3, they both have the same numbers, but one is positive, one is negative. So they're not parallel because they're not exactly the same, but they're not perpendicular either because one isn't flipped. So be careful, be mindful of those, because those are also neither cases. Okay. Questions about any of these three examples before we go on to the next page? Once you have finished number 3, go ahead to the next page. We're going to do number 5. Find the slope of AB, just like we were doing before. So 7 minus a negative 2 over 0 minus 0. What is our slope there? What would this simplify to be? At the end, yes. So right now I'm just going to put it as 9 over 0. If you know it's undefined, that's great. I'm going to show what would happen if you maybe forgot that in the process. For CD, we have negative 5 minus negative 5 over 6 minus 3. Which would be 0 over 3. So if you left these as 9 over 0, 0 over 3, what would you think these are as parallel, perpendicular, neither? Okay, because they don't look the same. They don't look like reciprocals of each other. That would be fair to say that these are neither. But if you simplify them, or remember to simplify them, we know that this one is undefined. 0 over 3 is what? Not undefined. What's the opposite? 0. And 0 and undefined are parallel, perpendicular, or neither. So that's where you have to keep simplifying. Remember that you can rewrite that a different way, because undefined and 0 will always be perpendicular. Okay. Questions on that? Okay. So we did a bunch where we had to find the slope. Now we're going to look at some equations. So number 9. Would those be parallel, perpendicular, or neither? We're looking at the slopes. Parallel. And we know the slopes are the same, but how else could we tell that these are parallel lines? The different y-intercepts. So the slopes are the same and they have different y-intercepts. These are parallel lines. What about number 10? Perpendicular. And how do we know they're perpendicular? The slopes are negative reciprocals. They're flipped. One is positive, one is negative. And let's do 11 first. What about number 11? Neither. Because these look the same, but one's a negative, And because one's a negative, they're not flipped, so they can't be perpendicular, so neither. Okay. Then there are some like 12 where you have to solve them first. So for this equation, how would we get this back into slope-intercept form? Subtract x on both sides. We have 6y equals, hold that one. Miss Thorson. I'm good, hurry. Yes. Yes. Thank you. Okay, Jake. What would be the next step in that? What would be the next step in that? After I finish writing the rest.
Divide everything by 6.
Divide everything by 6. So go ahead and do that. Your mom's here. Sorry. I think it's not recording or something. So this would be negative 1/6x plus 5. But some of your I can't speak today, equations aren't in the same place. So what would we do for the next one? Divide everything by 3. So y equals 6x minus 2. Would these be parallel, perpendicular, or neither? Alright, we're going to do a couple more of these and then move on to something else. Would number 15 be parallel, perpendicular, or neither? Why neither? Okay. So this is similar to this one where we have basically negative versions of the number, but because this is 1 and negative 1, if I did 1 over 1, that's just 1, and negative 1 over 1 is negative 1. So these are negative reciprocals of each other. So these are perpendicular. So be careful if you get a problem like that, because you may think it's a neither because of something like 11, but it's not. Okay. For number 16, we have to think about the slopes of these two lines. What is the slope of a y equals? Someone said it, which is not loud. 0. And what is the slope of something with an x equals?
Undefined.
So if we have a 0 and an undefined, those are parallel, perpendicular, or neither. Why they decided to do this today. What did you say? Perpendicular. If you wanted to graph it, so I'll do a short little graph over here. You can do this if you want. So the y equals 6 would be something up here. And then the x equals -1 would be something off to the side. So you can see they cross, they make that T. If you had two of the same thing, so like 2y equals 2x equals, those would be parallel. If you had one of these and one of these regular equations, that would be in either case. Questions on how to determine if equations or points are parallel, perpendicular, or neither? Skip the page in your notes that say parallel, perpendicular, or neither. Go to the next one that says something about writing. This is the second part of what you need to be able to do with parallel and perpendicular lines. You need to be able to write another. So you'll be given an equation. You'll be given a point. This part will be very similar to when we were writing equations through a point and a slope or through 2 points. But your job will be to come up with another equation that is parallel or perpendicular to the original. So that's what this kind of explains. And we have to keep in mind that parallel lines have the same slope and perpendicular lines have negative reciprocal slopes. Okay. And we're going to do these 4 examples. And then some of the ones on the back I'm going to show you in Desmos if you want to do any specifically, or I'll just show you in Desmos. So this gets progressively harder as we go down. This is probably the easiest example. If you're given an equation that has to go through this point that is parallel to this line. So whenever you get an equation, I would cross out the y-intercept because you don't need it. It will only confuse you. We are going to do this the same way we were writing equations with our point-slope formula, so I'm going to write that up here. Y minus y1 equals m times x minus x1. So if we are writing another equation that is parallel to this one, the slope of our new equation is going to be what? It's parallel to this one. You know, parallel lines have the same slope.
1/4.
What's the slope of this one?
Oh, 4x.
Just -4. So the new slope, or the slope of our new equation, will be the same, -4. So this would be our m. We have our x1, y1, and then we could use those and put it in this equation. Y minus our y1 is 7 equals our slope, -4, times x. I'm going to change this to a plus instead of putting minus minus. If you still want to put minus minus, that's fine. You just have to change it to a plus before you distribute. And then we could go ahead and distribute. Y minus 7 equals -4x minus 8. Remember, the end goal with these is to get it back in slope-intercept form, so get rid of 7 by adding. So that y equals -4x minus 1 is the equation that goes through this point that is parallel to the original. They have the same slope and different y-intercepts. Do you have any questions, confusions on how we got that so far? Let's do the next one. The next one is similar. Still still doing something that's parallel, but this one is not in slope-intercept form. So we have to change that to slope-intercept form first before we do anything else. So subtract x on both sides. Divide everything by -3. So y equals positive 1/3 x minus 3. This is not the answer to your problem. We just rewrote the original. So we can cross out the y-intercept. We don't need it. And because this says parallel, the slope of our new line will be what? Positive 1/3. So I'm just going to write m next to the 1/3 that I already have. If you want to still write it off to the side, you're welcome to do so. So now we have our m, we have our x1, y1. So we can use our equation and put all that stuff in. Y minus, actually this one I'm just going to put plus 1. If you want to put minus minus, you can. Equals 1/3 times x minus 3. Distribute, so we have y plus 1 equals 1/3 x minus 1. And subtract 1 on both sides. So y equals 1/3 x minus 2 is parallel to the original that goes through that point with the same slope and a different y-intercept. Questions on that one? Okay. So now in the next one, number 3 is similar to number 1, but with a twist. Because now we are writing an equation that is perpendicular to the original. Same as before, cross out the y-intercept, we don't need that. If it's perpendicular, what would our new slope be? -1/2. So this is where you have to think about the negative reciprocal. You have to do this part first. If you don't change it in your equation, then your work is now wrong and your equation is now wrong, so be careful with that. So change your slope and now put it into the equation. Y minus 3 equals -1/2 times x minus 4. Distribute and solve. Your final equation should be y equals -1/2 x plus 5. We can see that these are perpendicular. They have negative reciprocal slopes. The y-intercept doesn't matter. And it goes through that point, which I'm going to show you how that works here in a second. Questions on that process before we do this last one? This last one is about as hard as it gets, but it's like a combination of 2 and 3, because we have to change this to slope-intercept form first. Get rid of the 5x by subtracting. Divide everything by 3. So that y equals -5/3x minus 7. out the 7, you don't need it. -7. We have to find the slope that is perpendicular to this one. What would our new slope be? 3/5. We have our x1, we have our y1. Now we can use that new slope in our equation. So y minus 1 equals 3/5 times x plus 5 distribute salt. What was the final equation that we found? Do we have any questions about how we just found that answer? I want you to look on the back, find problems you want to see, do go over, have questions about, and then I'm going to have you grab your iPad. I have to unlock it first, so let's find problems first, and then I'll have you grab an iPad. On this page. Oh, not on the very back, just the back of the page.
Six.
Any others? I'm going to pick one of the perpendicular ones. 11. And then I have to grab my keys and go unlock that. Score number 6. And then type in the equation that's given, y equals 1/4 x plus 7. Negative 1/4 x. And then after that, we're going to type in our y equals mx plus b. And it's going to give you the option to add sliders, add all sliders. Okay. And we want this to be parallel to the line given so that the slope would need to be the same, negative 1/4. So we're going to change our m to negative 1/4. And then we're going to move the B. You can either hit the play or move it manually until it goes through the point 83. Move to this. And then we can see that the slopes are parallel. It goes through that point. So your equation that you would write, and for the practice part, you can use this on Delta Math as well, just you won't be using this on the test, on the quiz. But your equation that you would write would be y equals negative 1/4 x plus 5. We're going to do that one again, but does anyone have questions on how we just did that in Desmos? So now I'm going to change the information to make it 11, number 11 in here. So the point is going to be 2, 3. I'm just going to change this equation to exactly as it's written. I don't need to solve it in Desmos. So I would write it as 2x plus 10y equals 20. Now when you do this part in Desmos, because you're not given the slope, you have to count what your slope is. So it goes through this y-intercept, and it looks like it goes through this point. You could also count to this point. So I'm going down 1 and to the right 5, so my slope is negative 1/5. But this is perpendicular, so we have to change the slope to be the negative reciprocal. What would the negative reciprocal of negative 1/5 be?
5.
Positive 5 over 1. So I'm going to change this m to just 5. Now I see my point, and I see the original line, and I'm going to hit play or move this until it goes through that line. It was not going that slow a moment ago. So I can see that these lines are crossing. They are making that T. It is going through the point. So my new equation would be y equals 5x minus 7. Are there any other ones we want to see in Desmos before I have you try a couple? So you can try these by hand, by using Desmos. It doesn't matter. You can work together if you would like. Use your notes. I want you to try numbers 5 and 12. Try those two. Raise your hand when you finish them, and I'll check them. After you finish those two, here are the things you can be working on. So everyone look, pay attention for just a second. After you've gotten those two checked, you can either keep working in this packet. You can work on the Delta math that is due on Friday. If you want to finish your activity from last class where you guys were matching pairs of parallel and perpendicular graphs and equations, you will come see me for that. Or if you would like your review that we're going to do next class, you can come get that and work on that. But do those two, get them checked, then you can work on anything else.